Hey everybody, it's Miss Marin, and I'm back to talk to you this week about equivalent fractions. We're going to be using two strategies this week for making equivalent fractions. One is using models, and another one is using multiplication and division to generate equivalent fractions. This is the most important fraction skill we're going to do from now throughout the rest of the year, and this foundation is very important for what you're going to do next year in 5th grade and beyond. So when we make equivalent fractions, we're basically showing different ways of showing the same whole. So that doesn't make a lot of sense to most students because they think, how can different numbers be equal to the same thing? We have to remember that these numbers in a fraction are not numbers. They're representing a part of a whole. They're not a total amount. So we're going to show a couple different ways that we can show 1/2 using different size pieces. So the simplest way to do that is to split this just as this shows. We learned in our last video that this denominator means there's going to be two parts in my whole. In my numerator, the number on top is how many we're going to shade. So I'm going to split this into two groups for my whole, or two parts, and I'm going to shade in one of them. Well, we're going to learn that we can show this same amount shaded in using different size pieces. So if I didn't want my pieces to be quite so big, if I wanted to make this into a different number of pieces, I could split this also into fourths. So I split it into fourths. Now I'm going to have two of those fourths shaded in. Okay, it still shows the same amount shaded in, but it's using different numbers. Because when you have a larger denominator, you end up with pieces that are much smaller. So when I take fourths, these pieces become smaller, thinking like a pizza. If I were to cut my pizza into only 2 slices, they're very large. When I cut them into 4 slices, they become much smaller, so I need more of them to equal the same amount. Okay, and I'll do another one. Take my half again. Okay, I could take this 2/4 that I have now, split that again. Now I've made even smaller pieces. Now I have 1/8. How many do I have? I have 4 of them. So all of these fractions are equivalent to 1/2. Hopefully students will recognize with some patterns that 2 is also half of 4, and 4 is half of 8. And that is probably the easiest fractions to start understanding equivalent fractions with, is understanding what half means. These are just 2 equivalent fractions. There are an infinite number of other equivalent fractions that you can make. And the more pieces you make, the more parts you get here, the larger your denominator gets, the larger number of pieces you're going to need to shade in to equal that same whole, or that same half of the whole. All right, so there's a simple model for how we can generate equivalent fractions. All right, I'll try another one here. This is 2/3. So we're going to split that into 3 parts. We'll shade in 2 of them. Okay, so we want to use a model to generate some other equivalent fractions. I need to think about how many pieces I can turn my thirds into. Well, over here, we turned our half into fourths. I'm not going to be able to turn thirds into fourths. There's no way I'm going to be able to split this so that I end up with only 4 pieces. I could split each of these in half and end up with 6 pieces, and I have 4 of them shaded in. Notice I'm not changing the amount that's shaded in, I'm just changing the number of pieces I need to use to satisfy that same equal amount of the whole. So this is 2/3, and this is 4/6, and those are equivalent parts shaded in. Okay, one more. Okay, so here's still 2/3. Now I could take each third, paperweight. Now I split that into a lot more pieces. So I've turned my thirds now into, I split each one of these thirds into 4 parts. So now I've got 12 total parts. Looks like an array here, 4x3 array. And I have 8 of them shaded in. Okay, so it's another equivalent fraction. Now notice, as my denominator got a whole lot bigger, as I went from thirds to 12ths, each piece got much, much smaller, which is why I needed so many more of them to equal that same amount. So we're going to start off with models, but we want students to start noticing some patterns in here. And the patterns we're looking for is patterns of multiplication and division. So when I'm looking at this, I can turn thirds, we said before, not into fourths, because I can't multiply this times an equal number of parts in order to equal 4. But I can do twice as many pieces here. So twice as many pieces as that third to make 6, which means I need twice as many of the counted pieces, which is 4. So I'm multiplying this 3 times 2 to give me 6 pieces, and I'm multiplying 2 times 2 to give me 4. So really what I'm doing, I'm actually dividing it a little bit more, which gives me twice as many pieces. So we want to be careful about saying that we're multiplying this number by 2, because we're not multiplying the number by 2. If we were multiplying this fraction by 2, it means we take this and do that twice. Take this and another one. We're really multiplying it by 2 halves. 2 halves is also equal to 1 whole, so really we're not changing that number because we're multiplying it by a whole. Anytime you multiply a number by 1, you get that same number. So here we're taking that 3, and this time each third was split into 4 times as many pieces. 3 times 4 is 12. So my original 2 pieces that I had 4 times the amount there as well. So 2 times 4 is 8, and 3 times 4 is 12. So those are also equivalent fractions. So at the end of the week, what we're going to want students to be able to do is to generate those equivalent fractions without having to draw the model every time by using multiplication and division. So we could say we could take our 3/4. I could split each whole into 2 pieces. Okay, which would mean that I'm multiplying to get 6/8 would be another equivalent fraction. I could also split each whole into 3 parts, or 4 parts, or 5 parts, or 6 parts, or whatever I'd like. I usually try to keep my numbers as small and simple as possible, because when you get large numbers, what that means is your pieces are going very small. We don't usually like to work with small pieces. It's like working with money. Do we want to work with dollar bills, or do we want to work with pennies? Pennies are annoying to work with because the pieces are so small. Same idea. So 4 times 3 is 12. 3 times 3 is 9. These are all equivalent fractions for 3/4. And I could keep going on and on. Again, multiplying by 2 halves and 3/3 and 4/4 and 5/5 and 6/6, whatever I'd like. But again, the bigger the numbers, the more complicated and small those pieces get. I can also give you one like this and say, what if I gave you the denominator 20th? What if I told you I wanted my denominator to be 20ths? Would you know how many pieces I would need if we were doing 20ths? Well, I'm asking myself, if I had 4ths and I split them into 20 parts instead, what would I have done to each one of these pieces? Well, it would have been 5 pieces out of each one of those 4ths in order to make 20ths. So, by using multiplication of 5, you can see there's my 20 pieces. So each 4th is 1, 2, 3, 4, 5 pieces. So how many would I have then? 3 times 5 is 15. 5, 10, 15. Okay, so I have an equivalent fraction model where I'm coming up with my own fraction, and then one where I'm given a denominator and I have to find a numerator. All right, here's another example, working with 6/10. So 6/10, very simply, if I take each one of my 10 pieces and multiply it times 2 halves, I could turn this into 20ths, and I would have 12 of them. So 20ths might be something like this. But again, look how small those pieces got. Nobody wants to work with small pieces. We're going to learn that we want to work with fewer pieces, which means we want a simpler form. In the old days, we used to call this lowest terms. We're not putting anything into a lower number. We don't want to confuse ourselves with making the number smaller. We're just making fewer pieces, which is a simpler way to look at it. So instead of looking at the 6/10 I had before, this is my, let's go back to this. Those are my 10 pieces I had before. We could also use division to make this even simpler. So instead of saying tenths, is there a way that I could take this number and instead of multiplying it to get more pieces, I want to divide to make fewer pieces. Now this is important to understand. You can't just divide by any number you want. You have to divide by a number that's a common factor of both of these. So in this case, these are both even numbers. I can divide each of those by 2. Divided by 2 halves, then I could get 3/5. So what that means is if I make this instead, it's kind of messy here. Okay, if I make it into 5 parts instead, I'm actually making larger pieces and fewer of them. So this is 1/5, 2/5, 3/5, 4/5, and 5/5. Certainly much easier. Okay, certainly much simpler and easier to make 5 parts and shade in 3 of them than it would be to make 6/10 or even 12/20. All of these are acceptable equivalent fractions. This is the one that is the simplest of them all. It's in its simplest form. All right, here's 4/8. Is there a way that I can make this into a simpler form? Again, these are even numbers, so students might immediately think I can divide by 2. Okay, that would give me 2/4, which is a simpler form, but it's not the simplest form. 2/4 would be like this. So we do have 2/4 here, but there's an even simpler way. The simplest way is to divide by the largest common factor to both of them, which is not just 2, it's 4. So divide by 4/4, and I'm going to get 1/2, and that is a much simpler way to look at it. So if I just split it this way, I'm looking at all of this over here as one piece, and this over here is my second piece. So splitting it into 2 pieces, just like that, is a much simpler way instead of doing 2/4 or 4/8. All right, so equivalent fractions using models and using multiplication and division. We're going to continue using this skill throughout the rest of our fraction chapters, so it's really important that we master this skill. Thank you so much for watching.